Here we have a velocity that's given by its components. The x component is 4 meters per second. The y component is 2.5 meters per second. So we have a velocity, we have an object actually moving along some direction like this, but all we're given is that the x component of the velocity travels along at 4 meters per second and the y component at 2.5 meters per second, which is to say that if we travel at 4 meters per second along the x-axis and 2.5, and somebody else travels at 2.5 meters per second along the y-axis, we will each track this object, okay, moving in this direction. The question then is, what's the magnitude of the actual velocity, and what angle does that velocity make with the x-axis? Okay, now if you're familiar with trigonometry, you're familiar with the definition of the tangent function, and if not, this is it. The tangent of an angle in a right triangle is equal to the opposite side divided by the adjacent side, or the y component divided by the x component. So that the tangent of this angle will be the y component of the velocity divided by the x component. In this case, that's 2.5 meters per second over 4 meters per second, which I believe is 0.625. To find the angle, we take the inverse tangent. Now in a calculator, that usually involves using the second function or inverse key and then the tangent key. So we take the inverse tangent of the y over the x, which in this case would be the inverse tangent of 0.625, which is 32 degrees. So we can always find the angle by taking the inverse tangent of the y component over the x component. For any vector, if we know these two components, we take the ratio, the inverse tangent of that ratio, that gives us the angle. In this case, 32 degrees. The magnitude of the velocity, well, that comes back to the Pythagorean theorem. If we have a right triangle, x component here, y component here is the same as here. We could actually put the y component over here if we wanted to, and put these vectors head to tail. And we'd form a right triangle that forms this vector, and the hypotenuse of that right triangle would be the magnitude of this vector. Now we know that the hypotenuse of a right triangle is the square root of the sum of the squares of the two sides. Okay, so if we square this side and add the square of this side and take the square root, then we have this side. We do that for the present example. We add the squares of the two components of the vector, the 2.5 meter per second and 4 meter per second components, and adding the squares of those components, we get 22.25 meters squared per second squared. Now let's take a careful look at the units. When we square meters per second, we're squaring both the numerator and denominator of that unit fraction, or fraction of units, which gives us meters squared per second squared on each of these. And when we add meters squared per second squared to meters squared per second squared, we get meters squared per second squared. So we get the square root of 22.25 meters squared per second squared, and that's 4.7 meters per second. We then conclude that the velocity is 4.7 meters per second at an angle of 32 degrees, remembering our convention that this angle is always measured with respect to the positive x-axis going in the counterclockwise direction. Now, here's another example. In this case, we have a negative x component. We're moving at negative 12 meters per second with respect to the x-axis and at 15 meters per second with respect to the y-axis, which means we're going up a little faster than we're going over, and when we go over to the left. That's going to give us a velocity vector directed something above the 45-degree angle we'd get if these two were equal, and it'll look something like this. Now, again, we're going to use exactly the same techniques as before. The angle here is going to be the inverse tangent of the y over the x component, this time plus 180 degrees. Now that plus 180 degrees comes about simply because the x component is negative, and the inverse tangent function on your calculator is going to give you an angle that's either between, well, it's going to be between negative 90 degrees and positive 90 degrees. From the positive x-axis, negative 90 degrees is down here, positive 90 degrees is up here. The inverse tangent will never give you an angle in the third or fourth quadrant. It always gives you an angle, in the second or third quadrant. It'll never give you an angle in the second or third quadrant. It always gives you an angle in the first or the fourth quadrant. So to get an angle that's in the second or third quadrant, we recognize that if the angle's in one of these quadrants, the x component is going to be negative, so that when the x component is negative, we add 180 degrees to the first or fourth quadrant angle that the inverse tangent gives us, and that gives us the angle in the correct quadrant. So we do the inverse tangent of the y over x and add 180 degrees. The inverse tangent of 15 meters per second over 12 meters per second will be the inverse tangent of negative 1.25. That's a negative 12 meters per second in the denominator. When you take the inverse tangent of a negative, it will give you a fourth quadrant angle. In this case, I believe that angle is something like negative 51 degrees. If we add 180 degrees to that fourth quadrant angle, that brings us into the second quadrant and gives us a 129 degree angle. So that's the angle. The magnitude of the velocity, angle's 129 degrees, magnitude of the velocity is calculated using the Pythagorean theorem again, just adding the squared components, the x and y components, and the x component's negative 12 meters per second, the y component plus 15 meters per second. You square those and they both end up positive. You get 144 meters per second here and 225 meters per second here, which I believe it gives you 369, and the square root of that gives you 19.2. So that the resultant velocity is 19.2 meters per second at 129 degrees. Okay? And we note here, whenever the x component is less than 0, the angle is going to be the inverse tangent of the y component over the x component, plus 180 degrees to bring us over into the second or third quadrant.